The tan graph. The graph y equals tan of x of the function f of x equals tan of x is very different from the sine and cosine graphs. Some of the key features of the tan graph are as follows. So as tan of x is equal to sine of x over cos of x, tan of x is not defined when cos of x is equal to 0. Because remember, we cannot have a denominator of 0. We cannot divide by 0. And cos of x is equal to 0 when x is plus or minus 90 degrees, plus or minus 270 degrees, plus or minus 450 degrees, plus or minus 360 degrees, and so on. This means that there is a break in the graph at each of these values. So if we have a look at the graph down here, we can see at 90 degrees, there's a break in the graph. And at minus 90 degrees, there is a break in the graph. At 270 degrees, there's a break in the graph. And minus 270 degrees, there's a break in the graph, and so on. Tan of 0 degrees is equal to 0. So we can see that tan crosses at the origin. So we have the point 0, 0. So tan of 0 degrees is equal to 0. Tan of 30 degrees is 1 over root 3, which is approximately equal to 0.58. So if this is 0 degrees and this is 90 degrees, then 30 degrees is about here, and 0.58 is around here. Tan of 45 degrees equals 1. So if this is 0 degrees and this is 90 degrees, this is 45 degrees, and it goes up as far as 1 on the y-axis. Tan of 60 degrees equals root 3, which is approximately equal to 1.73. So again, if this is 0 degrees, this is 90 degrees, 60 degrees is around here, and it goes up as far as approximately 1.73. So we can see that our graph is starting to move upwards. So as x rises towards 90 degrees, remember this is 90 degrees here, the value of tan of x rises very steeply. For example, tan of 85 degrees is 11.4. As x goes up from 0 to minus 90 degrees, the same thing happens in reverse. So we can see that the graph shoots downwards. The y values become more and more negative, and the graph goes steeply downwards. As x rises towards 90 degrees, the tan graph gets closer and closer to the vertical straight line x equals 90. So this is the vertical straight line x is equal to 90. And as x rises towards 90 degrees, so as x gets closer to 90 degrees, the graph, which is drawn in orange, gets closer and closer and closer to this dotted purple line. This line is called an asymptote of the graph. So an asymptote is an invisible line that the graph does not touch. Other asymptotes are x equals 270 degrees. So see, here we have another asymptote, a vertical line that the graph of tan will not touch, but will get closer and closer and closer to it. We also have one at x equals minus 90 degrees, which is here. Again, the graph of tan will not touch it, but will get closer and closer and closer to it. And x equals minus 270 degrees, etc. The graph y equals tan of x in the domain x values from minus 270 degrees to positive 270 degrees, where x cannot be equal to plus or minus 90 degrees, is shown below. The tan graph is periodic. The basic building block for the graph is shown opposite, or shown below. So here we have one period of the tan graph, so one basic building block, which just gets repeated again and again and again. And the period for this is 180 degrees, or pi. The width of this basic building block is 180 degrees, or pi, if working in radians. Thus, the period of the tan graph is 180 degrees, or pi. The range of the tan graph is the whole set of real numbers, as the graph goes both up and down forever. The range of the tan graph is or the real number set. Thus, f of x equals tan of x is a surjective function, although it is not injective. So basically it's surjective because we could draw a horizontal line anywhere we want, and because tan goes up forever and down forever, we would always cross the graph. Later we will restrict the domain to make a bijective function.